guys. So for those who, in both cases, it was a cylinder with another, no, I'm lying. In the first case, sorry, it was a cylinder with another cylinder cut out. So that is number one. All right, so you're going to take the volume of the whole cylinder and then you're going to minus the volume of the part that's been taken out. Yes?
I was just wondering, like, the decimal places, two.
Yeah.
So, like, when you order two, that's it.
It is usually 2, yeah, but if they don't say it, then they can't really penalize you. But yeah, we usually say 2, so we try and practice that in class. Okay. Now for here, guys, the big cylinder, please notice that they've given us the diameter there of both of them. All right, and we know that in our formula, pi radius squared times height, we need the radius, not the diameter. So the radius of the big cylinder, because the diameter is 8, the radius is going to be 4. All right, and for the smaller one, the one that's been taken out, because the diameter is 3, the radius is 1.5. Okay, so that, and then the height of both of them is 25. So that's why I did that. So that is the volume of the bigger cylinder minus the volume of the inner one that's been taken out. All right, then number 2 was this cube. Right, so in number 2, it was the cube where you took out a cylinder again. So the volume of this cube, we see that all the sides are 6, right? And we remember the formula for the volume of a cube is 6 cubed. And then we're taking out the cylinder inside. Yes, Eve? They say there. Yeah, so they said it in the question, which runs through the whole height of the prism. Okay, so there we're going to take the volume of the cube, which is 6 cubed, or you can say 6 times 6 times 6, it's the same thing, minus pi times radius. Now, guys, if the diameter is 2.5, the radius of the cylinder is going to be 1.25, all right? So that's the radius squared multiplied by the height of the cylinder. Now, the height is the same height, or sorry, the cylinder has the same height as the cube, so that is why it is 6 there as well. Okay, any questions on those first two? Okay, then exercise 17.2. Let me just get that book so we can look at the questions. All right, you had to do 1C, which was that one. All right, so I think we can all see that it's a big rectangular prism, and then we cut away a cube. Right? Do you guys notice that that's a cube? So they indicated that in a funny way. They used like the same arrows, I suppose. All right, and we just had to understand that that meant that they're all the same length, but they actually should have used little lines, right? So sorry about that, but I hope you guys noticed that that meant, or kind of assume that it meant that they were all the same length, 2.5. So we're going to say 37 times 19 times the height, which is 8.5. That's the volume of the big thing. Then we minus the volume of this cube, which has been cut out, which you can write in 2 different ways. You can write 2.5 times 2.5 times 2.5, or you can say 2.5 cubed. All right. So there we go. You can write it like that, or you can write 2.5 cubed, right? That's fine. Both of those are fine. Any questions on that first one, on 1C? Now, guys, number 2 was short. I had to read through it a couple of times. I don't know if you felt the same way. In number 2, they said a wall is 4 meters long, 2.8 meters high, and 16 centimeters wide. Now they've given us meters and meters and centimeters. So let's change that 16 centimeters to meters. How do you go from centimeters to meters? What do you actually do? What calculation? Yes, thank you. Thank you. You divide by 100. All right. So to go from 16 centimeters to what it is in meters, you're going to say 16 divided by 100. Right? There are 100 centimeters in 1 meter. And because you're going from a smaller unit to a bigger one, you need to divide by 100. Okay, so I think finding the volume of the wall was okay. All right, because they gave us the 3 measurements of the wall. Obviously, we just had to do that conversion. So that is the first, or just the wall without taking out the, what did they say? Was it for the doorway? All right, so just the wall as a whole, we still have to minus the part of the doorway, which we'll talk about now. But are we fine with this first bracket here? The length of the wall is 4 meters. The height is, sorry, oh, I put the width first there. So it's length times breadth times height, right? All right, length is 4 meters. The breadth of the wall, the width, they used that word, was 16 centimeters, so 0.16. And then the height of the wall was 2.8. Okay, length times breadth times height. Are we fine with that one? Now we have to minus the part of the doorway. Now, yeah, the words that they used here was a bit confusing because they said now an opening that measures 80 centimeters wide by 2 meters high has been left for a doorway. Now, guys, if we can just look at that doorway over there, and we're thinking of this wall, all right, the length of the wall would be all the way down here. Are we fine with that? The height is obviously this. The width of the wall is that kind of width. It's going to be the same width as the gap as the doorway. I don't know if that makes sense, right? So if we're thinking of, say this was a whole wall and they had to cut out the doorway, right? The part that they cut out has the same width as the actual wall, right? So this has to be the same in both of our brackets. The breadth or the width of the wall that's left is the same as the part of the wall that's been cut out to form that doorway, all right? Because they're now saying they're using a different thing for width here. They're saying it's 80 centimeters wide, but that's actually almost like the length of the doorway, right? So that's like that gap of the door, where our width is actually this gap of the actual wall that's been taken out. It's a bit confusing, that wording that they've used there. All right, so this is what they say in words. It's 80 centimeters wide, but this is actually almost like the length of the door, if you think of it in that sense. Then the breadth of the part that's taken out, the part of the wall that's taken out, is the same as the wall that's left, 0.16. And then the doorway is 2 meters high, so that's the height of the doorway. All right, so the wording that they used there was a bit confusing. So just make sure that you have the same width for both of those, right? Because the part of the wall that you're taking out has to be the same width as the wall that's still left. Okay, so then you get to that answer there. I just rounded to, oh, they said you have to round to 3 decimal places. So just make sure that you have 3 there. It had to be 536, and then we just cube. Then the last one was just like that V shape that we looked at yesterday. So I think you guys would have been fine with that one, but let's just quickly look at the picture. So it was 4C was that last one. All right, so we're taking the volume of the whole triangular prism, the big one. Let's think the length, or the base rather, of the triangle is 15. The perpendicular height of the triangle is 13. And then the width or the breadth of the triangle is 1, right? Or the height of the actual triangular prism is going to be 1. All right, so that is the first one. It's half base times perpendicular height of the triangle multiplied by the height of the prism, all right? The distance between the 2 triangles. So that was the big triangular prism. Now we must minus the part that's been cut out, which is this bit here. Well, guys, we actually have to calculate this part, the base of the smaller triangle, all right? They told us that the whole length is 15. That is 5. And now we can see that these 2 parts have to be equal to 5 as well. Do we notice that? They've given us 2 lines and 2 lines and 2 lines. All right, so this base is 5. The perpendicular height of this triangle is 4,33. And then the height of the triangular prism is the same, is again 1. Okay. So that's what you did there. Any questions? I know I said yesterday that I'm going to give you the rest of this lesson to work on your corrections, but I do just want to give you a few more of these because I feel like you haven't really had enough practice in this stuff. Only 3 of these. So sorry, I'm going to give you surface area and volume questions and then 3 of these funny shape volumes. All right. So I'll leave this on the board. This is also from the notes, guys. There's at the end of the measurement notes, there's a measurement worksheet. All right. So if you want to, you can label this as measurement worksheet. And then for all 6 of these shapes, they want you to find the total surface area and the volume. All right, now we haven't done surface area in a while. Remember, surface area is the area of all the shapes that are on the surface, on the outside of the shape, as a solid. And then for volume, that's what we've practiced now. The volume of any shape is always the area of the base multiplied by the height of the prism. Okay, so we're going to do it for all 6 of those. And then on the back of this page, which I won't be able to put on the board now, but I'll post it on Classroom for you, there are 3 of these. All right, so these are it says they're more complicated examples. All right, so these are the ones where you have to find the volume of the bits that are left. Okay, so the volume of the shapes which have had a certain part of the shape taken out. So that one, that's number 1, that's number 2, and that is number 3. Okay, you're going to do those 3 as well. But first, you're going to do these 6. Right, you're doing surface area and volume for each of them, please. I'm going to leave that on the board now, but I will also post both of these parts of the worksheet on Classroom for you just now, okay? Do you have any questions before you get started? Yeah. Are you saying no, ma'am? Okay, I thought you just said ma'am. All right, guys, on Monday, we're starting new work. Okay, so this is the last now that we're doing on surface area and volume. So I need you to make sure that you know what's going on. Remember, you're also handing in your corrections on Monday. If you have them here, you can give them to me now. Yeah.
For number 1, that's at the bottom.
A 6.
Oh.
So it's 8 and 6 and 7. Yes. No, a separate thing. Guys, can you read all of those numbers? They're a bit faint, hey? Number 1, it's 8 centimeters and 6 and 7. Right, so 8 is on the side, 6 is at the bottom, and then that's 7. And then in number 3, can you make out those numbers? Maybe I must just go over them in pen here. That's 8 centimeters, 6 centimeters, and 7 centimeters. And then here we have a 9 and a 6, a 15 and a 12. These ones are very small. Can you make that out? Let me zoom in once and then you see. I don't know where this exercise is from. It looks like a mishmash from all different sorts of places. So those are 2s, and then that's a 6. 2, 2, and 6. And then the rest is fine, I think. Okay, start working on that, please, guys. So much is your name on it, please.
Surface area is
Mhm.
squared, right?
Yes. Yeah, area is always squared, volume is. Yes. Units, yes, yeah.